take you through the calculations which involve finding a side and an angle. So without wasting much of our precious time, I'm just going to draw a triangle there. This is not just a triangle because I'm going to do that. It is therefore officially a right-angled triangle, having those points. Maybe let's say there is an honorable member there who is walking, let's say, in that direction. So maybe let's say that is 12,1, maybe let's just say meter. Then let's say this angle there, it is 57 degrees. So this is a right-angled triangle that you are given, and the question may want you to calculate the length of ON, and they say correct to 2 decimal places. So remember, previously we said when you are given a right-angled triangle, if you are looking for a side, you need to use theorem of Pythagoras. But in this case, you cannot use theorem of Pythagoras because you do not have two sides. Because theorem of Pythagoras will apply if you have two sides and you are looking for another side. But in case if you are given one side and an angle, that's when you need to use sine theta, cos theta, or tan theta, which means those trigonometric ratios will be used in case you have an angle or an angle is involved. Remember, I said when it comes to a right angle triangle, you only need two things in order to calculate everything about that right angled triangle. So now they've specified, you say calculate the length of ON and correct to 2 decimal places. So that means this is you trying to find the side of a given right-angled triangle. So again, it's always important to be able to name your sides. You cannot do anything without you naming your sides. Obviously, this is the hypotenuse side, and this should be the adjacent side, and that should be the opposite side. So OA is our adjacent, and then what is it? We are also given the opposite. So we will be looking for that trigonometric ratio that has opposite and adjacent. So to easily find out, we can just do them. So car, and then we do the 2. So it is OA, so that means it is actually tan that we are supposed to use in this case. So easily and quickly we can just say tan of an angle is equals to opposite over adjacent. So tan, what is the given angle? It's 57 degrees. It is supposed to be equals to opposite being 12,1 meters. We divide it by the adjacent, which is the side that we are looking for. Remember, if you have a fraction on the other side, you also force this one to be a fraction where you divide it by 1 and then you cross multiply. So that means this will cross multiply that, that will cross multiply that. So that's why you end up having your A tan of angle 57 degrees, which is supposed to be equals to 12,1. And then from there, in this case, you can divide by tan. Remember, the only time you do that one of second function, that's if you are looking for an angle. But in this case, it is actually the coefficient that we are looking for. So that is why you will divide both sides by tan, where A will be equals to, let's see what we get when we punch on the calculator. It has to be in degree mode. You will do the fraction button 12.1, and then they will say tan of 57 degrees equals to, it gives 7.9. Very much important to round it off to 1 decimal places, and most importantly the units, it has to be in meters because originally you were given that in meters. So that's why your final answer also has to be in meters. If it was an angle, it would be in degrees. So maybe very quickly, at a speed of light, let's move on to the second one. I'm pretty much sure that what I've done there gave you an idea of what is expected of you. Maybe very quickly, let's do this as our example number A, or letter A. It's fine, doesn't really matter that much. Let's say this point is called point P. So when we say a point, we are simply referring to a corner, being corner P, and then corner U, and then corner N, and that angle there being theta. Then you are given that side being 10 meters. Then this one, let's say, at 16 meters. So this time around, it looks like it is an angle that we are going to be looking for. So what we did previously was to calculate the side. So now we are going to be calculating the angle. Again, SOHCAHTOA, very, very much important. You need to always remember your SOHCAHTOA because it will tell you which trigonometric ratio to use. SOHCAHTOA. Okay, then it's fine. So now let's see, what do we do? And naming the size important. So 16 meters, I don't know what happened there, but it's supposed to be 16 meters, and definitely this is our hypotenuse because it's opposite the 90 degrees. This is our opposite, that should be our adjacent. So how you choose is based on what you have. Do we not have the adjacent? We do, which is 10 meters. Do we not have the hypotenuse? We do, which is 16 meters. So that means we look for a trig ratio that has A and H. A and H, that means it is C, C for cos. So that means we will say cos of an angle should be equals to, we know that cos of an angle equals to adjacent over hypotenuse. Therefore, I can just nicely and easily continue. Our adjacent is 10, our hypotenuse is 16. Then you can just say cos of, then you do the second function of 10 over 16, and this should give an answer. Let's see, shift cos 10 over 16, 51, did I mention, let's just round it off to one decimal place. It will therefore be 51,3. You have to say degrees because it's an angle. Just make sure of that. Very, very much important. Okay, so let's do B. Then when it comes to B, let's see. For example number B, that's not complicated. We can just do something like that. Maybe let's put an angle there. So you'll see that this right angle triangle, it can be presented to you in many different forms. And then maybe let's say here it's 1.2 centimeters. Let's say this is corner A, and then corner F. Let's just say corner N. Maybe the angle, let's just put it there. So we have two positions where we can put that angle, but for now we'll just put it there. And what are we going to do? Naming of the sides. Very, very much important, that one. Obviously, this should be the hypotenuse, and this should be the opposite, and definitely that being the obvious one being the adjacent. Okay, then it's fine. From there, we have O and A. Definitely is tan, TANUA. Tan is the trig ratio that has opposite, which is being divided by the adjacent. And then remember, it is the angle that we are looking for, and then we will say opposite being 1.2, that needs to be divided by 13. And then this is the angle where you will do the arc or the that, and then you've got 11.2 that you need to divide it by 13, and that. Then what you do, just punch it on your calculator. So maybe let me just make you aware that I also make mistakes, honorable member. So just do it as I do it, and in case if you find something and you get different thing, firstly suspect that you have done it correctly. No, not correctly, incorrectly, and then try to work it out as many times as you can until you get the answer that I got. I think the mistakes that I normally make are easy to spot, but for some reason when something is complicated, I just don't easily make mistakes. I don't know why, but otherwise it's fine. Let's continue. I think I did all that I wanted to do with regards to the finding of the size and the finding what? Not the finding, but the finding of an angle. So now let's come to what we call angles of elevation and angles of depression. Let me just write it down there and say angles of elevation and depression. Those are the two types of angles that we are going to be looking at. Nothing complicated, nothing difficult there. Maybe let me just schematically represent what those angles are. So you just have a straightforward right-angled triangle there, where let's say this is corner N, corner F, maybe let's say this is corner U. Doesn't really matter that much. Then you see this angle that I'm about to do, that angle name, let's call it angle theta there. Maybe let's just add another a triangle that we will compare with, right angled triangle. We'll do that, then we will say N, then we will say U, then we will say F, and then here this one I'm going to do this. You see this that I am doing, we'll refer to this as a beta. So these are two right angle triangles positioned in the same way, but let's interpret them and say this one of theta, that angle we call it angle of elevation, which is the angle from N to F, or it's an angle of elevation of N from of F, I meant to say from N. It will obviously be from N. And then this other one of angle beta, it is the one which is the angle of depression of N from F. So you will always attach the from with the corner where that angle is formed. So something very much important that you might need to be aware of. You remember under what is it, Euclidean geometry or geometry of lines, where if you have that Z, they say this angle is the same as that angle, or that angle is equals to that angle. So that means again that beta should be equals to that angle. Just be aware of that for now. It might be valuable information. Okay, then it's fine. Maybe let's try and do a practical example, something that you can relate to, and see how we make use of that knowledge. Let's say there is this cliff here. Yes, a cliff. I'm not sure if you know what a cliff is, but you can just Google it. Just think of a big mountain, but on the other side of the mountain it's like they've just cut it like that, whereby obviously this is maybe the ocean or the sea or something like that, and then you've got what is it, what is this thing, a ship. Yes, you've got a ship there, a very nice one, Yes, you've got a ship there. Then, let's say the distance from there to the cliff, meaning from the ship to the cliff, let's just say it's 70 meters. See, then now, the height of the cliff, let's just say that height of the cliff, it will obviously be from there to somewhere, and there. That height is whatever h. So it's like now we are now trying to practically use what we know about trigonometry to solve real life problems. To say if there is that ship which is 70 meters away from the cliff, and the cliff is this high, so that means there will be that line from there to the top of the cliff, whereby we can simply measure that angle, of which let's say it is given to us as 55 degrees. So all of this is what you will be given. So the question which you may be asked is to say, what is the angle of elevation of the top of the cliff from the boat? So based on what I've just explained not long ago, to say if you are given this angle, mathematically we know that it is the same or equals to that angle, because this is that angle of depression, this is the angle of elevation. So automatically it means this angle there, it is our 55 degrees. See, not that much complicated, but it's straightforward. Then something that they would want you to calculate, it is the height of the cliff. So let's see, we do have this side. What is it? It is our adjacent, because the 90 degree is there. Then obviously this is our hypotenuse, and what you are looking for, it is actually the opposite. So it looks like tan is what we are going to use. So you will definitely say tan of an angle should be equals to opposite over adjacent. Our opposite is what we are looking for over our adjacent, which is what? Our adjacent is 70, and then doesn't matter whether tan angle is on the other side, this is equals to that. Then said that you can make it a fraction, then you cross multiply, and then you end up having your h being equals to 70 tan of an angle being 55 degrees, and then you have 70 tan of 55 degrees, which is equals to 99.97. If we round it off to 1 decimal places, it just forces it to be to the nearest. So when you punch it, you get 99.97 and whatever. Then you need to round it off to 1 decimal place. Then you add there, it makes it 10. The 1 goes there, it makes it 100. You would rather say 100, 0 if you want to force it to be to 1 decimal place. Okay. It looks like I did all that I wanted to do in today's lesson, and I'm pretty much sure that you did understand how to use trigonometric ratios to find the sides, not only the sides, but also to interpret the angles of elevation and angles of depression. Nothing complicated, nothing difficult. You just apply your knowledge as you were taught. Okay, I think I'll leave it here, because I was just trying to check if I did everything that I wanted to do, and I have not made those obvious mistakes. It looks like everything is okay. Okay, then it's fine until we meet again.